Kia ora, and here's question 1C from last year's school algebra exam for level 2. So this question is one where you have to think about the discriminant. So here it is here. For which values of k will this equation have two distinct real roots? Okay, so the first thing we have to say is, what does it mean for something to have two real roots? So for two real distinct roots, we need to think about the discriminant. So we require b squared minus 4ac to be strictly greater than 0. And in this equation, we've got a is equal to k, b is equal to 5, and then the tricky bit is to say, well, what's the constant term? And c is equal to negative k plus 5. And we can write that as 5 minus k. That might make things a little bit easier, but it doesn't really matter. So now we just have to substitute in and get an expression for b squared minus 4ac. So that equals 25 minus 4 times k times 5 minus k. So 25, take away 4k times 5 minus k. Expanding that out very, very slowly here. So minus 20k plus 4k squared. And we need to have that be strictly positive. So if you got that far, that was an achieved code. So what we have to do now is to take this and solve the inequality for k. So the first thing to do to work with the quadratic is to reorder it. We've got 4k squared minus 20k plus 25 is strictly positive. And we always want to watch that this number is a positive coefficient. It makes life much easier, but that's fine here. Now, if you take a look at this term here is a square. It's the square of 2k, and this is the square of 5. So let's see if it fits a perfect square pattern. Let's try 2k minus 5 times 2k minus 5. So let's see if that worked. Well, we've got 4k squared minus 10k minus 10 more k plus 25. And we need to have that be strictly greater than 0. Right, so if you got that far, you're up to a merit mark. The trick here is to interpret what that inequality means. We're looking for which values of k will give me a strictly positive expression. But if you think about it for a minute, we've got a number here, 2k minus 5, and when we square it, we want it to be strictly positive. But that will work for any number. If we have negative 17 squared, that's positive. Negative 1 squared is positive. 325 squared is positive. There's only one value for which this is not going to be strictly greater than 0, and that's when 2k minus 5 equals 0. So we can't have 2k minus 5 equaling 0. So let's look at what that gives us. Well, if we have 2k equals 5, k is equal to 5 over 2. So that's the only number we're not allowed. So my final answer here is k is any number except 5 over 2.